Good morning, students. It's me, Smita Miss. It is our social science class for standard 9. And today we can take social science second. Last week we discussed about the first lesson from social science second. And in that lesson we already discussed about the various processes through which the atmosphere is heated. And do you remember which are they? They are conduction, convection, advection and terrestrial radiation. And do you remember insolation and terrestrial radiation? What is insolation? Insolation is the incoming solar radiation. And what is terrestrial radiation? Terrestrial radiation is the outgoing radiation from the surface of the earth. And what is the difference between these two? What is the difference between insolation and terrestrial radiation? Insolation is in the form of short waves and terrestrial radiation is in the form of long waves. Isn't it? Yes. So, last day we discussed about another important one, that is greenhouse effect. This greenhouse effect or global warming is happening because of the greenhouse gases. Which are those greenhouse gases? They are carbon dioxide, carbon monoxide and methane. These three gases are the main greenhouse gases. The greenhouse gases like carbon dioxide, carbon monoxide and methane can absorb energy, heat energy. That is why the temperature in the atmosphere increases a lot. It is because of the increase in the amount of these greenhouse gases. So today we can come to another important aspect, that is a major part of the distribution of the temperature in the atmosphere. Which is that concept? That is heat budget. Do you heard about heat budget? No. Okay. Do you heard about budget? Yes. What is budget? Budget is the statement that includes both income and expenditure sides. I think you heard about national budget, state budget, etc. And in the same way, there is family budget. What is a family budget? A family budget is the income and expenditure sides of a family for a month. And if the income and expenditure sides are equal, that is called a balanced budget. Here, the heat budget is also a balanced budget. But instead of income and expenditure, here the insolation and the terrestrial radiation is balanced. Then we can give a definition to heat budget. That is the balance between insolation and terrestrial radiation is called a heat budget. We can repeat it. The balance between insolation and terrestrial radiation is called a heat budget. Now we can discuss heat budget with the help of a diagram. You can see a diagram of heat budget in the screen. Look at the screen and here gives a diagram. That diagram shows both insolation and terrestrial radiation. If insolation is 100 units, the terrestrial radiation must be 100 units. Then also it will be balanced. That means how much of solar energy is absorbed by the earth should be re-radiated back to the outer space as terrestrial radiation. That means the amount of heat energy absorbed by the earth should be equal to the amount of heat energy re-radiated back to the outer space. Then only it should be balanced. This kind of a balance between insolation and terrestrial radiation is called a heat budget. Now we can see the diagram. In that insolation, 14% is absorbed by various dust particles, gases and clouds in the atmosphere. We know that greenhouse gases are there in the atmosphere, dust particles are there, and in the same way water vapor is there in the form of clouds. And all these particles, clouds, dust particles and various greenhouse gases can absorb heat energy. It absorbs 14% of heat energy. 35% of heat energy is radiated back to the outer space. 35 plus 14%, total 49%. If the total insolation is 100%, how much is remaining? That is 51%. Remaining 51% reaches on the surface of the earth and earth absorbs it. And 51% absorbs the surface of the earth, and this earth re-radiates this 51% to the outer space. And during the re-radiation, 34% is absorbed by various dust particles, clouds and gases. And only remaining 17% is re-radiated back to the outer space. 17% is re-radiated back to the outer space and 34% is absorbed by dust and clouds. 34 plus 17, total 51. Then this is called a heat budget. Is it clear now? Total insolation 100%. Out of this 100%, 35% re-radiated back to the surface, outer space, 14% absorbed by dust and clouds, 51% is absorbed by Earth's surface. And out of this 51%, 17% is re-radiated back to the space and 34% is absorbed by dust and clouds. Is it clear now? Yes. Now we can see a diagram, not a diagram, a table showing the balance between insolation and terrestrial radiation. Here you can see a table. And the left side of the table shows in the amount of insolation and the right side shows the amount of terrestrial radiation. Now look at the table. Amount of energy reflected by the atmospheric particles and Earth's surface will be 35 units. that we already discussed. Energy reaching the Earth's surface will be 51 units. And energy held by the atmosphere is 14 units. All these we discussed earlier. And total energy received by the atmosphere and surface of the Earth is 51 plus 14 units, that is 65 units. 35 units is reflected back to the outer space. So only 65 units is remaining on the surface of the Earth and in the atmosphere. That is insolation. Then about the terrestrial radiation. Direct terrestrial radiation is 17 units. Radiation from the atmosphere is 48 units. That we discussed. That means 34% and 14% is absorbed by dust particles and clouds. 14% from the insolation and 34% from the terrestrial radiation. Total energy or total radiation from the atmosphere is 48 units. So, the total energy radiated back from the Earth's surface and the atmosphere is 48 plus 17, that is equal to 65 units. Is it clear, students? Now, in this class, we discussed about heat budget, and this heat budget is a balance between insolation and terrestrial radiation. If insolation is 100 units, the terrestrial radiation must be 100 units. All the energy received by the surface of the Earth should be re-radiated back to the space or radiated to the atmosphere. Here in this heat budget, the Earth's surface is absorbed 51% of energy, and this total 51% is re-radiated to the atmosphere and outer space. I think it is clear to you now. So it's time to wind up today's class. We can take the next part based on the temperature in the atmosphere in the next class. Okay, thank you.